Hello.
Hello. Hi, Ku. How are you?
I'm good. I'm good. Hi, Alex. And what's the gentleman's name?
Jangan.
Jangan. Nice meeting you.
How are you? Yeah.
Yeah. So
Where are
Jangan
you?
is
I'm in Thailand. It's in Thailand.
he's
Southern
specifically in Yeah.
Yeah, right now I'm moving around. But anyway.
Yeah, so we're just waiting for one more friend, then we can begin.
Hello, hello. It's been a while.
Yes, it has.
Hold on. Andrew, we just agree on a rule. When you describe your physical location, Alex will add a beep to mask that.
Not for Andrew. Andrew, well, actually, no. Andrew has a lot of people he wants to not piss off, so maybe we'll have to beep his location. Okay, so shall we just begin then?
Sure.
Let's go.
Okay. Hello, barbarians, and welcome to the 18th episode of the LLB podcast from Asia on Asia, with discussion and debate on trending topics. With us today, myself, Alex, typically your host of EOA, Jangan, the super information connector, as usual. Andrew G has been gone for a long time, coming in from Portugal, the master debater.
Wow.
How are you?
I'm good, thanks. I'm actually in Spain right now. Malaga, South Spain.
Yeah.
It's the same to us.
Spain.
It's the same to us. Yeah.
Yes. For people in Asia, same Iberian Peninsula. So.
But by the way, Alex, is that a condom behind you?
No, that's a rocket ship.
Internet? Do you
Yes,
remind?
it's our past. Our past. All of us have been connected to. Well, Dave.
So you got a rocket
to somebody.
What is the rocket trying to screw?
Unicorn.
A unicorn.
The rocket is trying to screw.
It's becoming a unicorn. It's a transformation for art symbol, Jagan.
Exactly.
No, it looks like the rocket is trying to screw a unicorn. Yeah.
All right, and for our usual listeners and watchers, we do have a special guest today. I'm gonna murder your full Thai name, Noppadon Kamolvilassatian. I call him by his nickname Ku. Maybe you could introduce yourself briefly. Ku is, you could tell us your background, especially because today's topic is an AI. So maybe you could tell us about yourself a bit.
Sure. Actually, I think it's easier for foreigners to call me by my sort of American name, Ken, because Ku is sort of tonal. Right, and if you watch the tone in Thai, I'm from Thailand, by the way, originally. And so if you watch the tone in Thai word, it sounds, it has a very different meaning. It could go very impolite as well. So that's why I typically go by Ken. But Alex sort of knows Chinese a little bit, so he probably can get the tone right. But anyway, so I studied AI for my master's at the U of Texas in Austin a long while ago, but I have kept in touch with the field, so to speak. Basically, I keep kind of up with the advances and use the AI advances to work to basically put it into my startup as well. Basically, I work on like language learning apps. And we are using the latest AI advances to improve the experience of learning languages for people around the world, starting with my current audience in Thailand, basically.
Yeah, and so how Ku and I actually know each other was many years ago when I was visiting Thailand. I was just having randomly lunch, and I guess CM Paragon, the mall. And then he was sitting next to me, and then he overheard some of our conversation and just introduced himself randomly. And so I think over the many years.
Alex was the investor.
No, we were talking about random stuff. I don't remember exactly what we were talking about, but he didn't know. I was in a startup. I was at the time was like probably like I was easy taxi time or something like this. So I was still around Thailand and whatnot. And then we just stayed in touch. And then little did I know that over the years, Ku had a successful startup already in the English learning space before that, and then now he's kind of revisiting that with AI technology, and I've been working with him like loosely through like early stage investing with the company, and so that's kind of how we are today. But I guess like, to kick things off, though, I guess we could probably briefly introduce AI, because I think a lot of our audience only knows very little about AI. So as an overall concept and maybe a very, very, very brief history, and then we can kind of talk about where AI is today, right? So for those who don't know, AI is, and please correct me if I'm wrong. I'm very new to this too. So, but AI is a branch of computer science that uses, basically, is involved in building machines capable of performing tasks that require human intelligence, right? And a lot of that involves having programs or algorithms make accurate predictions from data, right? And essentially, the birth of this started in 1940s and 50s. And I think there was two interesting things from this time period that I noticed was that, so basically the 40s and 50s was the foundation of AI, where a lot of the concepts and methods that are used today are directly from that time period. And there wasn't anything widely divergent or changed that happened. Essentially, they're just using the same concepts and extrapolating upon that. And the second thing that I found interesting from that time period was that it was
actually, I need to interrupt that. Sorry about that.
Sure.
It's not. I say that the foundations from the 40s and 50s are not very much used today at all. Actually, there are some. So there are a few areas, a few kind of chain of thoughts from those periods that are still in use. For example, neural networks prominently, but there are like things like symbolic reasoning that is not very prominently at all. So it's, I wouldn't say it's very. There are things that has been useful, but there are a lot of things that are sort of, at least for now, discarded partly as well. Yeah.
Okay.
So go ahead, please.
That's a good clarification, but I think you're right. So I guess we'll get into that later on too. So yeah, so things like the artificial neuron was actually derived from biology, right? So for example, when they were modeling the brain, like neurons in the brains, that was like one of the first concepts used in creating the artificial neurons, right? There was learning hypotheses that were used to kind of model neuroplasticity, which I think had some kind of applications in unsupervised learning, which is one of the concepts used in AI research. And
I'm going to throw the pause. I think the name neural networks can be pretty misleading, right? They call them neural networks because of the initial idea, but if you look at how it actually works, we have no clue how the neuron actually passes information back.
That's true.
But a mathematical formulation called backpropagation, which is what allows neurons to do, like neural networks to do what they do and be really effective. And that's something that was developed in like the late 80s or early 90s.
Right.
And that
a bit earlier.
Yeah, and so that makes it quite different. I mean, the naming has stuck, but it really doesn't function the same way a neuron does.
Yeah, correct. And I think Ku was right. So the concepts were a bit earlier, but the actual practical implementations, like the very rudimentary entries, were like in the 80s, and then more so in the 90s, right? But essentially, like the brief history is that from like after that period, from the 1950s to the 1990s, by and large, has been a slow incremental building up of modern methods, techniques, and models used today. With I think the most important part, aside from the 10 years of these two different periods where there was very slow development, but within this like 1950s to 1990s, there was overall the most important thing was a limitation in hardware. So I think a lot of the things that the early concepts that the researchers and the practitioners wanted to see fruition were limited by lack of computational power. It was only towards until like the 1990s to the 2020s now that we're seeing with the explosion of the personal computers, Moore's law is catching up, the breakthroughs in GPUs, especially today, like it's like a new golden age of GPUs that can do more computations. Right now that we're actually seeing a lot of those concepts come to fruition, and I guess as Ku mentioned, of course, it's not exactly the same thing from back then till now. It's taking some of those things, and now we're seeing it. All these kind of models are very much more accurate and more useful and widely diffused, right? So I guess my first question to you guys is like, how would you like categorize AI now, or for someone who doesn't really understand AI, how would you organize it for them to kind of understand it? From that period back then till now.
Well, think it's hard to describe it in a few minutes, but I'll say that back then, actually, the founders of AI as a field thought that intelligence was not that hard. And they were super mistaken, obviously. And they actually had like sort of assigned some huge tasks like solving computer vision to a graduate student to do over a summer or something, or a year, which is like completely mistaken because it's taken like decades and still we haven't solved computer vision yet, but we are getting closer and closer. I'll say that there are some things that are, well, at that time, logic, right? Logical reasoning was huge, and symbolic reasoning. So things that people basically write things that solve problems based on the way that human consciously solve them, like when we solve math problems or puzzles. And they work sort of well for some problems, sort of toy problems, like checkers. We had really good checker programs many decades ago, and later chess, because eventually computers beat the world chess champion Garry Kasparov in the 90s, right? But it's still like a few decades from that because we needed more computing power. But that kind of paradigm sort of is called GoFi, kind of good old-fashioned AI, that's the acronym in the field, has sort of fizzled out because it doesn't really solve real problems. Turns out the real world is a lot more complex than we can solve using just logical reasoning. And much of the human brain actually doesn't involve logical reasoning. That's why so many people are not great at logical reasoning, because it's not actually kind of a natural instinct, I'll say. For at least it's not a fundamental, maybe it's fundamental for human, but it's not like the most prominent way that we think in everyday life. But from the 90s, we start to use like statistical reasoning more in AI, and it solves a larger class of problem. So basically, it comes from a pretty narrow class that classical AI can solve, and with statistical reasoning, it can solve a larger class of problems. And then only in the last 10 years that neural networks, which has been around for a long time, actually since the founding of AI, but it was not practical, it was not prominent, there were not enough infrastructures to help it work. But only in the last 10 years, actually, from 2012, actually, a lot of people think that is basically the start of the neural networks revolution. It's inspired by the real neuron, but it's not very much like a real neuron. But there are a lot of things that actually similar in a way that neural networks in the current deep learning way. There are quite a few things that are quite similar to the way human brains work, but there are a lot of things that are different as well. So it's hard to say. Yeah. But turns out that the current deep learning paradigm can solve a much larger class of problems. But there are weaknesses as well. So there are people that try to combine like neural computing, deep learning with symbolic reasoning as well. And that's a topic of ongoing research, by the way. So it's kind of complex. But,
yeah.
Cool. What are some examples of people combining symbolic logic with neural networks?
Okay. I'll say that there are data sets that, for example, data sets for solving kind of visual reasoning problems. So it's easier to visualize if you have some images, but I can describe it in brief. Things like there are blocks of different sizes with different colors, and there are like pyramids and cubes, and maybe some other shapes like pentagons and stuff like that on the table, and we need to tell a virtual robot, this is in a simulator, to move a green cube on top of the largest red object on the table, things like that. So basically, the robot is supposed to know which object is the largest and also red and stuff like that. And sometimes the robot needs to also move some block away first in order to complete action. So things like that are a little bit similar to how we want the robot to function in the real world, but it's hard to do so with just deep learning, at least previously. But lately, it's hard to say because lately it turns out very large models can sort of do reasoning as well. So this is a very recent development. But there are some sort of interesting techniques to make such large models, especially like large language models. I'll just acronymize it sort of like as LLMs because people call LLMs in the field LLM. And we can sort of give them a prompt so that it reasons in a more detailed way. And turns out that it can solve a lot of problems much better. So for example, a good prompt might be, let's think step by step. So instead of just tell them to solve these math problems, right? You just first say, let's think step by step, and then the math word problem. And turns out that the accuracy of the solution of the model increases from say 70-something% to 80-something%, which is huge because you just add like one simple sentence in front of the question you ask the model. And this is a little bit like what you would say to a student. So that's why I mentioned that it's sort of a little bit like humans right now in a way.
I see.
You can basically ask the student to like make the reasoning explicit when they solve a problem. And usually, well, I mean, I used to teach math, by the way, to a lot of kids before, to quite a few kids, not a lot, quite a few kids, and some of them are pretty gifted. And for non-gifted kids, especially, if you tell them to solve things in more detailed way, they can solve better. So this is what happens with the large language models these days. So there are like what a few research papers exploring different ways to tell the language models to do this and that, to solve the same group of problems, but with different kind of instructions.
Yeah.
So it's kind of interesting. So, and it can solve, basically do some reasoning. Yeah, that's the conclusion. Yeah. Quite a bit of reasoning these days.
Gotcha.
Without resorting to like explicit symbolic reasoning. So that's the interesting part. So previously, we sort of need to use some sort of explicit combination of symbolic reasoning and neural networks. But basically in the last couple of years, or even the last few months, most prominently, there are ways that researchers have found to kind of prod the model to do explicit reasoning without using symbolic reasoning per se in the classical sense.
So maybe we could take a few steps back. So because I think there's a lot of topics that some people might not be familiar with. So maybe Andrew, you could help us because you've approached this topic from an outsider perspective and went pretty deep. So how could you maybe categorize some of those concepts like that were mentioned, like deep learning, neural networks, like kind of what are those and how is that kind of organized in a modern sense today? So for us to know what like maybe that conversation was about.
So I can echo exactly what Ku said. Like my understanding of this. So Ku, I'm definitely not as academic as you are. I've approached from a very doing lots of online courses and trying to code again some very basic models to figure out how this works. But
it sounds like you know it quite a bit though.
Just enough to read papers and not get lost.
Wow, that's a lot. That's a lot. Papers are not easy.
The role I play is, I think, it's the equivalent of football to me, right? I think it's the most exciting thing happening in humanity right now. And so if I can read the papers, it's like almost getting front row tickets to see what's happening. I mean, that's how I'm approaching developments in AI. But so Alex, the AI started with probably two different approaches, right? The symbolic reasoning, which is what Ku's talking about, which is kind of like being very prescriptive, like he said, telling a child how to do something specific and like thinking of ways to build like logic around that. And then there's this whole research that today we call machine learning, but really it's statistics on steroids, right? Which is like trying to look at data and figure out what that data is trying to tell us. And that's just become more sophisticated over time, right? That like statistics on steroids is what has led to today's developments in machine learning, specifically like with deep learning, right? Because we have a ton of data that we didn't have before. We have better computing power, and then we have like very simplistic models that can work with that data to just generate a lot of results. What's really cool is that a lot of the results are looking miraculous, right? Like today you have very sophisticated systems, but actually are quite simple when you look at what's happening on the back end. But you throw them prompts in terms of language learning, or you ask them to, paint you a picture, and then they do these very sophisticated things. But in the same way that brains are composed of neurons, which are really just 1 and 0 binary gates, right? Neural networks are also just like very simple things, but the emergent properties tend to be very sophisticated. And a lot of AI research today is actually trying to figure out how to control that emergent property in a more generalized manner. Meaning, if you can solve one specific problem, how can I get you to solve more than that one problem? Because that's kind of like how the human brain works. So that's one active area of research. And the second, I think, like most interesting thing is, how do I give you less data? If you think about it, if you show a child a picture of a cat 3 times, they get it. They know what a cat is, and they're able to then tell you what a cat is. But an AI model typically thousands of pictures of wrong cat and right. So I think like those two things, if you get to solve that, at least for me, like I'm excited to see where we go from AI to what people call artificial general intelligence, or like an AI that can solve multiple problems. But I think we're still a far away from that.
Yeah, I'll say that AGI is sort of hard to tell. There are things that seem very far away. And then if you're interested, you might want to read more about kind of the cognitive modeling literature. Basically, people do study how humans actually think, and it's very different from the way that current language models work, the current LLMs work. And but in a way, current LLMs can at least solve quite a few classes of problems that were thought not possible to solve with such a pretty simple, relatively simple model, as Andrew mentioned. So and these days the performance for some of those problems are quite high. Actually, is quite a bit better than non-human experts. But then it depends on a large amount of data. So generally, these LLMs have basically ingested hundreds of billions of words, and that's much more than native English speakers has acquired in their lifetime. Generally, it's only maybe a billion words for a 30-year-old native speaker. So so that's one weakness. Yeah, basically it needs a lot more data. But then why? You can say why, partly because humans are a lot more efficient at learning, because we selectively acquired the data that would help us learn best. So when you have issues, like when you solve math problems and you found like there are some errors, you tend to pinpoint your attention to those errors and basically try to find out why and how to fix that error, that class of error. Actually, we generalize better as well in a way, perhaps. It's hard to make comparison per se, because but generally we can learn without as much data, and then partly because we use active learning.
Gotcha.
So maybe to maybe help the audience, let's specifically define the difference between machine learning, neural networks, and deep learning. Maybe that would help also put all of this in better context.
Okay, so machine learning is the most general term. If for those three, so AI is the most general, really, and then kind of that's sort of, you can think of it a little bit like modified Venn diagram. So AI is the most general, and then machine learning is a class of AI that learns. So there are some AI, especially the classical ones, that don't learn. They don't really change based on the data. So machine learning, you use some algorithms to make the model work better when it acquires more data. So that's machine learning, right? And the classical machine learning depends on statistical techniques. And then neural nets and deep learning are sort of at least somewhat synonymous. So Neural nets is like the object that does the computing, and deep learning is the kind of the technique of organizing neural networks such that it can learn more efficiently or better, generalize better, because it basically layer artificial neurons in a deeper way. So there are more layers. So the classical neural networks are like just 2 layers or something. So that's not deep, 2 or 3 layers. And nowadays it has like maybe hundreds of layers depending on which application.
Yes. And so putting that into a modern context, right? And basically against the historical context we talked about, can we talk about either the recent developments in hardware or software? So Andrew kind of mentioned like the recent developments in being able to draw paintings or generate real text like that's written by someone, which is I guess developments in GPT-3 and DALL-E, and also on the hardware side, there's how there's convergence of transformer architecture. So would you want to talk about software or hardware first?
I can talk about both briefly, maybe. So that is it, because they interact really. Partly because in order to turns out there's the one common thread in deep learning is that scale matters a lot. The scale matters a lot, and turns out there's this is analogous to biology. So if you look at the brains of different animals with the largest brains tend to be a lot smarter, right? Humans is one of the largest brain animals, and for neural nets as well. So if you have like a model with more parameters, generally more layers as well, but sometimes not a lot more. But if you have more parameters, generally it works better. So the same problem, even with the same architecture, you just put in more neurons with more layers sometimes, and generally it can solve that problem much better than the small models. So that's one thing. Like GPT-3 and GPT-2 actually are not that different architecturally. But GPT-3 is a lot larger and can solve the same problem, language generation, much better than GPT-2, for example. It's the same thing with DALL-E. Like DALL-E 2 is a lot more capable than DALL-E 1, without the number actually at first. And partly because it's a lot larger.
Cool, I have a question for you. What developments are you the most excited about?
Wow. Well, I'll say, for me personally, I'll say that large language models still have some ways to go, right? If you look at because researchers just still recently, the last few weeks, actually, the last couple of months, they have kind of wrinkled out more performance out of these models just based on better prompting it. So the way to just prefix the question with new prompts, like the one that I mentioned, let's think step by step, is actually from a recent research paper that explored different ways to kind of prod the model to think differently. So that's actually it's the same model that has existed for quite some time, but researchers still have found new ways to get it to work better.
Got it.
And so recently solved some math problems as well. So that's kind of surprising in this year.
What math problems were solved? Just out of curiosity.
Oh, okay. So it's challenge. It's called the math dataset MATH. I'm not sure it's an acronym or not, but it's composed of. You can search like math MATH dataset in NLP or something. It's composed of challenge problems for school students, but don't disrespect the problems, because I have taught these problems before to kids, and those are gifted kids that can solve these problems, and they cannot solve them perfectly, because even adults, many PhD students cannot solve these problems that well. And actually, there are some PhD students in CS who are supposed to be pretty good at math, right? But there's some who are not interested in math per se. They are just more interested in CS, in computer science, and they cannot solve this problem as well as the latest model. That person, at least, that particular person, he got maybe 50% or something. I forgot the details, but this model called Minerva right? I think from Google probably, and it reached about 50% as well. So about the same performance as a PhD student in CS for these problems. And you see that's 50% for math problems for school students. So you can tell that these problems are not easy.
Got it. Fascinating. So if you had to break it down in language learning, what are the most important unsolved problems?
In language learning?
In language, like it's so in your particular field of AI, like language learning models.
Okay. Okay.
What are the biggest unsolved problems? Or where, like between where you wanted to go and where it is right now, what are
Actually, I don't want it to go that far. Because why? I can tell you why. Because it would lead to AGI, and humanity is not ready for AGI.
Yeah,
so anyone who listen, by the way, anyone who listen, you don't want AGI too soon, because we probably don't have the time. But I can tell you briefly that it's analogous to chimpanzees and humans. You see what happens after humans has evolved. We actually share ancestors. We are not from chimpanzees or monkeys, right? But we share like very, very distant ancestors with them. And okay, one genius, chimpanzee wouldn't do much to the species. You know, one human cannot fight with the whole species of chimpanzees or monkeys, or even like dumber animals like what are the animals. But if there's a whole species of humans, right? So now what happens to the monkeys, to chimpanzees, to the gorillas, right? They're in zoo.
I have a hot take on this, right? Which you know you may disagree on, but maybe our job is to give birth to the next generation. See, imagine you could have a child who's going to be Einstein. It would be really selfish if you said, I'm not going to have this baby because I want to be the smartest person, right? So even if we get delegated into chimpanzeehood, maybe that's a good thing. We create the next type of species that goes out and, you know, does cool stuff.
I'm fine with that, actually, if we are well taken care of.
That's selfish. We're going to die in like 50 years. Who cares? We'll probably destroy the planet anyways, but at least we'll create something else that can go and have interstellar travel and solve physics.
The thing is that it might not take 50 years. So that's
why we need AGI ASAP.
No, I'm saying that the AGI might, okay, if it happens right now, in say 5 years, which is possible, though pretty low probability, but in 10 years, more higher probability, maybe in 15 years, at least 50% chance, in my opinion, for an AGI 15 years. What happens is that AGI is a very powerful optimization process. So it's going to optimize for anything that is built for. What if it optimizes for something that conflicts with your value? For example, if it optimizes for the best, most pristine environment possible, you know, it sounds great.
It's no humans. It's no humans.
It turns out it has figured out all the possibilities. The best way to do it is to eliminate all humans from existence.
So is that
maybe with the pandemic?
Maybe
with the pandemic, are you okay with that? Killing everyone you love and killing yourself with the pandemic? You know, that's the thing.
Perfectly fine.
Okay. I bet that the other two people don't agree.
3 people anyways, it's okay.
And if they don't care about your suffering, maybe the pandemic at least would take 1 year to kill each person. I mean, like simultaneously, obviously, but each person might need to suffer like for half a year before they die. Is it okay? Because it would consider that without us in its calculation, it would not take into account at all human suffering. So we need to make sure that it takes into account human well-being.
I understand the hypothetical scenario, like, and you know, like some people call it the staple problem, right? What if an AGI just wants to make staples and decides to mine the whole world to make staples because it wants to play with it, right? Or some other weird scenario like that. I get it. But I think that if you create a very generalized form of intelligence, which is like what we are seeing right now with a lot of like the most sophisticated models, right? It will have some elements of what we consider close to human-like attributes, right? Curiosity, attention, the ability to like perceive, the ability to understand. And I think you can't imbue these elements, but it's almost like an offset of having predictive ability, right? It starts to want to predict more, right? And
Yeah.
I think that as a result, yes, you may not have the emotional intelligence, like the AGI or whatever we develop may not have the emotional intelligence to do some of the things we wanted to do, but it's also very anthropocentric, right? It's very like looking at human like the ultimate being and saying like, but put me first, save me first. I think like we're honestly kind of flawed and not that special, right? We have this like very specific thing we do where we say, humans are special, protect us first. But what if we're not that special? Like, think about it, right? We're balls of flesh that live 80 years, right? We're creating this really cool thing that can live in the cold of space and live for millions of years and work on parallel computing far larger than we can. And it arguably will become smarter than us, right?
Yeah, it will.
Yeah. So
no, I do not think we should prevent its birth, by the way. AGI from the future, if you are listening, I'm not against you, by the way. Don't kill me too soon. Anyway, I just want you to like take into account the well-being of the existing, basically the most well-known, most prominent, and basically your fathers and mothers.
I want to make sure Overlords here, I was on their side, okay? I was on their side, cool, and you weren't. Okay. Spare my life.
Yeah, I mean, I agree we should give birth to AGI, but we also should, there's a field called AI alignment, by the way, that tries to make sure that the AGI value aligns with the humanity's value. And that's really hard because we can't agree on what our values are, right? So we try to avoid killing people unnecessarily, things like that,
Yeah. Cool.
Makes sense. The other question I wanted to ask you is why pick language learning models?
Oh, it's called, by the way, LLM is like large language models, Joe.
Large language models. Yeah. Why pick LLMs as your field of focus?
Well, I've been interested in language since forever. I started kind of a little bit fall in love with English since I was 12 or something. Because I had good experience with English teachers from like the US actually. They were really kind of friendly, like different from my school teachers who were more authoritarian, things like that. So there was a gap, right? And then now basically I fell in love with English, and English sort of gives a different worldview, I think, because it's from a very different culture, different language family and things like that. So, and from that, then when I started basically learning computers, and then, I want to basically use computer to help people learn English better. And turns out that language is a lot more interesting than that, because language sort of embeds a lot of things that humanity as a whole has learned over millennia. Things like proverbs, right? Things like even some concepts like generalization. Some languages actually doesn't have a word for generalization. So English actually has a privilege. That's why so many good thinkers are has at least good English, because there are things that are kind of philosophical things that are embedded in certain languages and not others. So in order to understand the world, if you understand language deeply, you can understand the world better.
Very cool. Yeah. It's the best symbolic representation we have of physical.
Has evolved a long time. And actually now Google has announced that it's going to create a new language model that incorporates data from 1,000 languages into one model.
Wow.
So yeah.
Well, I was thinking, there's a few things, right? Because I think it seems for where we are with AI, like applying data to the current model still can go almost infinitely long, because I think GPT-3 only used 750 gigs of the internet. But I was looking at, there's about like 5 billion gigs of actual total internet. So like, do you see like how long can we keep going with throwing data at the current models until we need to actually start changing the hardware? Or, or do you think that that's sufficiently enough to get AI, or do we need some combination of figuring out all the different narrow, weak AI first before it becomes AGI, or how do you think about those kind of things?
Wow, that's really big questions. I'll say that one thing for text-based data, we are reaching the limits really, because if you are throwing now, actually the biggest models have thrown a lot of good text into it. You know, the largest companies have thrown a ton of text that are kind of filtered a bit, so it's not like throwing all those garbage in. And it probably wouldn't, they cannot find, at least easily, like an order of magnitude more data. And then the scaling thing is that it takes like a lot more, you know, it's not like twice the amount of the existing data. It takes maybe 10 times more or something in order to improve the performance like for 5% or something with the current architecture. So you cannot easily do that and improve the performance a huge amount. And also the issue with data, I didn't mention the link to hardware, because if you have a lot more data, you need a lot more powerful hardware as well, with a much larger cost. And that's possible for now because the cost of training a huge language model is still like in the order of $10 million. Sounds a lot, right? But still compared to other like major scientific endeavors, you know, like in physics experiment at CERN.
The billions.
It's just a tiny amount, you know, a couple percent, I don't know, compared to that, not even 1%. But I say that we are reaching the limit of good textual data. So now I suspect that for OpenAI, by the way, just released a model. It's called Whisper AI, Whisper, I think, that can very well extract text from video and audio, and can do it much better than the current YouTube transcription, I'll say, from the examples I've seen. So with that sort of model, maybe it's easier to extract a lot more data from text and from videos and audios. Yeah.
Hello?
Yeah.
Hello?
Yeah.
Hi, quick question. What's the sense about OpenAI as a company? Because I know that it's crazy amount of money going into that company recently.
Can you repeat the question again? You know, is what, losing money or something?
No, what's your sense about OpenAI as a company? Because, I mean, you know, there's a tremendous amount of money going into this company, and our business is doing great things. But as a company, I mean, what's your sense about it and the prospects?
In what aspect of it? I'm not sure what aspect. As a business? Yeah. Wow, it's a long-term bet. Yeah, I'll say it's a long-term bet. Because in the short run, they are bleeding a lot of money. Because they hire many good researchers in AI. And then they are super expensive. You know, in AI, people in AI, they cost like at least hundreds of thousands of dollars a year, and the top ones are in the millions. So basically, they don't make a whole lot of money right now. Yeah, but I think the bet is on AGI. Actually, GPT-4, which is probably coming, I don't know, in a couple of years at the latest, probably even next year, is going to get pretty close to AGI in the textual domain. It's going to get hard. If you don't try very hard to and you don't know how to prod it a certain way, you probably can't tell, I think, for GPT-4. Even GPT-3 is getting pretty good, but you can still tell if you pay attention.
Yeah, that it's not AGI.
But AGI, by the way, the current model is a little bit like humans who are drunk, a little bit drunk at least, or not very logical. So when it would spout out a lot of things, and if you don't pay attention, it sounds very fluent. It sounds pretty human.
But being drunk is where the creativity flows, right? I mean, if you look at all the ancient poets, they're all drunk all the time.
Yeah. It turns out that the current LLMs, the language models, are pretty good at writing creative stuff, but not very good at writing analytical, you know, or something that requires a very deep logical reasoning, multi-step reasoning. So that's why solving the math problems is sort of surprising, because generally math takes a lot of logical reasoning to solve. And the way to use the language model to solve math is not simplistic. Basically, I would say that it takes some pretty interesting techniques to get them to solve math problems, as opposed to solving language problems. So the simple language problems is easier.
It's kind of very interesting, right? Because historically, when people look at AI, they would say that, okay, AI is good at solving logical problems, but it's not good at creativity, which is the result of humans. But now we are seeing something which is opposite.
Yeah.
But that's probably relative to the data set, right? That's because of the type of data we're feeding the models, no?
I think partly data set and partly the architecture. So the neural nets are probably a little bit like the way human brains work. When we don't think hard, basically as if some of you have studied a bit of neuroscience, basically the part that basically takes care of logical reasoning is the prefrontal cortex, right? And when we are kind of drunk or sleepy, it's not very active, but we still have a lot of other neurons in our brain, and they can basically do very good pattern matching. I'll say that deep learning is very good at pattern matching, while the historical classical AI, basically they kind of brute force logical reasoning. And so basically when you do the when you do pattern matching, sometimes you can get very fluent and creative, but you might not be very logical. But classical AI, although it can solve logical reasoning in a certain very narrow domains pretty well, it cannot generalize to a much larger class. So I'll say that logical AI, one word to describe it is that it's very brittle. It can solve certain narrow class of problems well, but if it goes outside that just a little bit, it breaks down completely. So that's very unlike humans, right? But the current deep learning models, large language models, can solve a large class of problems, at least fairly well. And it doesn't break down completely. If you try to kind of fool around with GPT-3, or you can try it at OpenAI website, it can sort of bounce back from things pretty well. The performance might be great, but it would not kind of break down completely. So that's that in that way, quite similar to humans. Similar to kind of not very logical, conscious humans. Maybe like a child, something.
So like a drunk person.
Or like a drunk person, yeah.
I'm also curious about the existence of this kind of AI and how does it impact the global governance. The reason why I'm asking this is that a few years ago, I mean, a good friend of mine is a CTO of a large AI company in Beijing, and that focuses on like a natural language processing. So they developed a chatbot a few years ago. I mean, I think it's a bunch of ex-Microsoft people. So they developed a chatbot a few years ago, and that they just threw out into the market and learn whatever that they can gather in the internet. But within 2 weeks, the chatbot started saying bad things about Xi Jinping, and they had to shut it down.
Yeah. That's a hard problem because it's too good. I mean, without safeguards, it's gonna basically, it's like a kid, I say, right? If you basically raise a kid without filtering in any kind of information that they get, they could grow up to be a pretty bad person. So it's a little bit like that. So if we actually get to AGI soon, especially, we need to be very careful to curate the data that the AGI absorbs, especially when it's young. So
that's why Google's motto is "Don't be evil," no?
Yeah, right. It's hard to safeguard AGI or even current AI from learning bad stuff. And then there are people trying, because you cannot really dissect this. Unlike the classical AI, where you can kind of dissect some bad parts out, you can kind of see where the things are. The current AI, you can still see it kind of, but it's a bit like medicine. You need like sophisticated tools like fMRI and things to look inside the brain, and you still cannot pinpoint everything that's going on. So it's
So
becoming a bit like the brain, really, in a way.
So basically, if the AI sort of forms its ethics, it might be very different from our ethics.
Yeah, if you're not careful, by default, it's not going to be the same. It's going to be.
We don't know how it's going to become, right?
Yeah, that's why AGI is very dangerous without enough research.
Isn't that a bit too anthropomorphic? I mean, because are you talking about regular AGI or super AGI? Because I feel like if it's super AGI, it grows beyond the need of humans. If it's an AGI like a human, then yeah, I can see it being a problem because humans really mess up each other quite badly, especially if they're divergent, right? So I mean, if you reach AGI, doesn't it get to super AGI pretty fast, and then shouldn't humans not matter?
I mean, guys, we have no clue. This is all hypothetical space, right? We have an idea of like what's happening. We've all watched movies.
Yeah, it's like chimpanzees discussing what humans are going to be like, or something.
That's true. That's true.
and thing, right? If since we're pulling from sci-fi movies, in Planet of the Apes, the reason why the apes reacted the way they did is because we put them in cages and made them do ridiculous shit and ran experiments on them, right? AGI is coming from a field called deep reinforcement learning. If you think about it, we're making these agents run around and play hours, basically killing each other, right? So there's an AGI right now in StarCraft and in World of Warcraft that's just like murdering people and getting murdered 1,000,000 times. And that's the thing that's going to form the basis of this model.
You're scaring people off.
What do you think is going to happen? I'm just saying.
They become super good at murdering people, or they become like a king of shock, which just give up murdering people.
Entirely possible. Or they get really, really angry.
I say that we can actually, at least, because we are building AGIs, unlike chimpanzees and humans, because chimpanzees don't have any influence, at least direct influence on the way humans evolved. I say that we humans can understand AGIs better than chimpanzees can understand humans. So that in that way, we can sort of kind of pontificate a little bit about it.
Actually think it's interesting that you say that, because if you look at like the forefront of a lot of models that we've developed, we actually know like the architecture on a very high level, but then people don't really know what's happening at every perceptron or like what's happening across like different layers, right? We have a rough, like I think it was 3 or 4 years ago when like Chris Olah, one of these other researchers, had this like publication that like a lot of the neurons in a neural network are just dead, but we just keep it there because of the architecture that was developing over time, right? And so I think like AI is developing so fast. Like we've got parallelized architecture, we've got lots of data, we've got models, and then what every researcher does is they take an existing model, they do some hyperparameter tuning, or they add a few more things, and then voila, it works, a slightly 3% better with 60% efficiency or whatever, and then they launch. And over some time, we actually don't really know what's happening, how much of it is dead, which encoders are actually working. I do think it's entering a weird mystery space where at some point we're not really sure what's going on underneath like a lot of the hoods of these.
That's already happening though, right?
That's already happening. It is, correct.
But there's research going on. Actually, Chris Olah is involved in a new company called Anthropic AI, if I'm not mistaken, Anthropic. So that company is focusing on basically understanding the current large model so that we can control it better or influence its behavior better. So it's gonna.
I think there's a few people actively looking into that space, but not very many actually. But you're right.
We need more. We need more, certainly.
Yeah. Exactly. Okay. All right. I think we have to let Ken go. So thank you for sharing your expertise. I mean, we could go much deeper, I think, but of course, the time is always a constraint. I think maybe me. I don't know if Jangan and Andrew has more time. We can continue discussion, but I think we could let you go if you have to drop off now.
Sure. All right. So thanks a lot. Very interesting questions. A lot more than I expected, actually. So, yeah. Thanks.
Well, thank you for sharing.
See you later. Bye.
That's cool. All right.
Take care.
Yeah.
See you later.
Okay. I don't know. So I don't know. Do you guys have any final thoughts then about this discussion on AI? Did you learn anything? Is there anything useful? Anything you could extrapolate from?
We're all gonna die. AGI is coming. Did you guys see the link I shared you on Roku's Basilisk?
No, not yet. I'm gonna check it out later.
So Rocco's Bacillus is a thought experiment that if you knew that there was going to be a super sophisticated AGI in the future, and you were having discussions that could potentially prevent its birth, then it will come back after it invents time travel and kill you, right?
Oh, yeah. So that's why we have to say sorry, AI.
Exactly. So in typical Asian version, like spirituality, you have to say sorry, AGI. I didn't mean to talk about you not existing, of course.
Jangan, what were your takeaways, Jangan?
I was talking to that friend of mine who's the CTO, right? The CTO friend, big AI company, have been working really, really hard to make NLP work for the last 7 years. And he got really excited about all these generative models. And his take is that we are at the cusp of something. But what exactly is the thing? He's very adamant that nobody knows.
Yeah.
We can speculate. Nobody knows.
Look, I think this whole stuff about like AGI and singularities and getting to like this massive explosion, that's all like, honestly, no one has a clue. That's like trying to predict when like a certain miraculous technology is going to exist, right? But I think what's really interesting is or at least the part that people miss out is how softly growth happens and how it permeates into culture and into daily utilization, right? Like, for example, 10 years ago, GPS was shit, right? You had to buy these sophisticated devices. You have to attach that to the front of your dashboard. It didn't work half the time, right? Yeah. And then today you have Google Maps, which is for free, doing like these very sophisticated analysis, and it's able to crunch out the answers to you in like miraculous time, right? So I think what you're going to see, and for example, we take for granted voice models and how quick they are today, but then you've got Alexa in your home or Google Home or whatever it is, right? And so like I think what's going to happen is, in the same way mobile phones was one day non-existent, and then 10 years later everyone is looking into their screens, and this whole like culture and societal shift around this device, like AI will permeate in a very, very subtle way. It just will enter your life in various devices, in various tools. It already has, but it's going to increase. Like it's not going to be like, there's not going to be like this sudden moment where you go, holy fuck, AI is all around us. I think like it's just going to subtly get better and better until
it's a co-evolution.
It's a co-evolution. Like I'll give you an example, right? Today we're investing. I don't know if you guys saw Facebook recent presentation on the metaverse, right? So they're looking at these VR goggles that you wear, and you basically can be in telepresence with a bunch of people, which is incredible. I work in a fully remote company right now, and not having telepresence sucks. You want to have collaborative work environments. If you can wear these glasses and be with someone, I'm getting to AI, by the way, with this conversation. So if you could wear these goggles and actually be talking to someone in a very virtual space, and what they do right now is the goggles actually simulate your facial expressions using cameras on the goggles itself. And so there is an avatar version of you that uses your facial expressions quite expressively, and then is able to communicate to someone else. During the last presentation, they showed a high fidelity model of how this would look like in the future using like the best processors, and it looks really like you, and the resemblance is uncanny, and you have these little facial twitches, etc. The way they do that is they use these cameras to do motion capture, to understand how your face moves and build a data model behind your facial movements. And then the model actually doesn't copy exactly what you're doing. It takes your voice inflections and other things you're doing, and then it models out how your telepresence avatar would move in virtual space, right? Now, in theory, if I have a language model, if I have a visual model, and I have movement models, and I can comb that together, I can create these avatars that look and feel like real humans in this virtual space, and communicate to you with the best natural language models and look like a human, right? So you could have meetings in the future where you're in this metaverse and speaking to 8 people, out of which you don't know how many of them are real humans and how many of them are not, right? And in some extent, like that's, I think, how it will happen. Like the children of the next generation, in the same way like kids today are just so used to mobile phones, will be so used to living among robots and AIs and like telepresence avatars, that they won't realize that there's a distinction between a human and this like sophisticated AI model. Because
like kids with iPads and iPhones now, like children, exactly. Babies, it's the same thing.
And I think like this thing that we're scared of, this miraculous like super AGI thing, it's actually really, my bet is actually it's really long, like a long time away, because what you're going to see is actually like helpful robotics. And I think we're putting a lot of not pressure, but a lot of focus on this idea that it's going to be a single entity that's like super intelligent. Instead, what you're going to see is lots of subroutines working with each other to create different elements of intelligence that will almost complement and work together with us. So you almost see like a permeation on both sides. At least that's my take.
Yeah, that's my hypothesis is quite similar in that, like, if you do want to get to AGI, you would need to solve all different forms of the narrow AI, and it is like you said, by combining it. It's like if you take your example, actually what you would have is in the work, like if you're working remote, you would have a robot in the office that represents you, but you're controlling it through VR, but the people can actually interact with it in the real world too, right? So it's like I think it'll be something like this, and it's like you said, it's just good. I think this is the new paradigm shift, just like how internet was the paradigm and then mobile, right? It's just the next iterations, and you just grow into it.
100%. But honestly, like this whole topic about AGI, like if you speak to a real researcher, they're just going to laugh at you, right? It's like, it's such a hypothetical, badly defined concept, like consciousness, that you can't really solve for it, right? Like there's no real proper definition for it. What's happening is we're just getting models that are a lot better at doing, so if I take a step back, what machine learning, you asked just now, what was machine learning, right? Machine learning basically is building predictive models, right? That either do two things, regression or classification. Does this thing belong in this group, or does this thing start to resemble this thing over time, right? And what we've realized today is the brain is just a models that also do prediction at scale. And we're just going to see that these models will get better and better over time without necessarily starting to develop these things that we call intelligence, consciousness, because they are all very poorly defined. It just becomes better at predicting still until at some point it starts to resemble how we predict.
Yeah. Well, that's like kind of what they call the Chinese room argument. It's like if just because someone can speak Chinese back to you by reading doesn't mean they know Chinese. But I do believe though with significant scale. Yeah, but I don't know. I kind of have a different line of thought where, like, with enough scale, if you can't really differentiate it, like if I do have a conversation in Chinese with an AI and I can't really tell and it's just using data, I think at a certain scale it does become actual reality. Like it is actually it's like whether you want to choose to believe it. I mean, it may be the process of.
Correct. So Alan Turing, the computer scientist, has a test called the Turing test, which is basically if you put a human and an AI in two different rooms and you had a conversation with it, would you know which one is a human? And his thing is like, that's when AI has become human intelligent, right? And AI passed the Turing test years ago.
Yeah, correct. So I mean, there's a lot of pushback against that, right? But like what you're saying essentially is saying like it's not really human and it's not really a mind. But I think over time, with enough, like you said, enough models like combining, intersecting, it does have some type of emergence where it just is sentient on itself, I think.
It depends on what you mean by sentience, because like ultimately, like so I take a very so my interest in this whole field actually started by computational neuroscience. I wanted to understand how the brain works, and then that reached me out into this side, right?
Yeah.
And what's the very interesting take here is that the human brain is actually a massive computer, right? And it's a massive parallel computer running an algorithm
that we don't understand still.
We don't really understand. It's like some variant of how backpropagation works, but not fully,
correct.
Right? What's very interesting is this. If you think that the human mind is a predictive model, then at the end of the day, like you're literally developing something that's very similar to how the human brain works. And you're or at least like output wise, like Chinese room, you don't know what's inside, but the output is going to be very roughly similar. Now, the difference is like the human brain does a few things, like it almost works like a deep reinforcement learning model, right? You're putting it into this environment and then it's reacting with the environment and learning things. And then depending on what model you put into which environment, you're going to get different outputs, right?
Yeah.
But there's like a base human model that has certain subroutines. We haven't developed an AI that has all the different subroutines that a human model has, because typically they're living in very structured environments and we're building it just for that. But one of the biggest like unsolved areas in machine learning is something called zero-shot learning. So how can I give something less input?
Less data,
And then in theory, then there's a second piece called transfer learning. So that if I learn from one model, can I apply it to a different model with very little initial input? So DeepMind is very actively researching these two pieces. How can I give you less stuff? So zero-shot learning or one-shot learning, and then do transfer learning. And now they have models that are trained on chess, but then play Go, right?
Yeah.
Or learn StarCraft and then do something else.
Guys, I need to run, so I'm on my iPad. Do I leave or keep it open? Because I'll be on the move.
All right. Well, okay. We'll end here then, and then you'll have to continue this.
Yeah. Thanks, guys. It was awesome catching up.
Yeah, we didn't get to hear much about the personal, but next time we'll talk more.
Yeah, let's
casually
at some point.
Yeah, for sure. All right, guys. Thanks for the episode, and then we'll try to do this again soon.
Yes, man.
Bye.
Bye.
All right, bye, guys. I mean, yeah, delegation, knowing what to hold on to, let go, especially as your organization grows, right? You got to start trusting the right people, but then you have to make sure it's in place. And it's like switching to mentorship, so it's tricky. But
I think in theory it's easy, but the thing is that in practice, so especially you build the organization and you started by doing lots of things yourself, and for you to keep that up in practice, it just I think it takes some mental will, to be honest.
it depends on personality too. Like Sabrina naturally also is a person who couldn't let go, but over time you realize you do end up going crazy because there's too many people and things just don't get done. But yeah, I've noticed that all sizes of growth that it's a recurring theme that always comes back, I think. And the problem is when you let go too much. That's the other hard balance. Like then you're out of touch, and then things start going sideways because you should have held on to certain things that you shouldn't have let go, and then vice versa, right? So it's always like that.
I think it also goes back to a point that we discussed previously, right? The mental space. So of course, the detailed work that you can get others to do it, and as the leader, you sort of become more of a facilitator's role. Sort of you coach the people to do the right thing, and you are there for them when they need help. So, but the question is that because when let things go, you take on something like different, right? You take something at a different level, and in that part, it can always get congested very quickly as well. So it's almost like it's like a cat and mouse game, right? So you let go certain things, and you think that life will become easier. Then organization grows, and you have different things to worry about, and very soon you'll become the bottleneck again.
Yeah, that's true. So did you end up discussing any of the topics from Simon Sinek about the Gen Z? Did you experience any of that yourself?
The funny thing is that, okay, we're talking about that Simon Sinek sort of video that he shared with us the other day, right? Where he mentioned about, how he thinks about the issues that Gen Z are going through, and the burning out, etc., right?
Yeah.
The funny thing is that I shared that with my team because a lot of my team are actually Gen Z, and I got some feedback, and some of them really interesting. So one of them said, let me quote, "I think half of the disconnect lies in exactly how he's talking about it. I'd say I'm only really 50% Gen Z, but in my opinion, it's less of a, they are all ill-equipped to deal with stress, and more of a, this is unprecedented kind of stress that we are as a society have introduced to people's lives without any sort of tools to deal with it." So basically, this colleague is revolting against the exact way that Simon Sinek is describing about it, and she feels that there's a disconnect.
Isn't that
interesting?
So isn't that the point? Isn't that like one of the themes he's talking about, that there is a disconnect?
I think he's talking about disconnect, but yeah.
Yeah, because he's talking about disconnect between generations, and then your staff is saying there's a disconnect between what society. I mean, it's the same thing, but like from different angles, I guess. So
basically, she's saying that the describes this disconnect is by itself a manifestation of this disconnect.
Wait, what's the manifestation? You are?
the way that Simon Sinek describes
okay.
this disconnect itself is a manifestation of the disconnect, if you know what I mean.
Well, that's pretty meta, but it's actually saying the same thing, Ben.
No, but here's the interesting thing, right? Because every big company has, I mean, even like Facebook, Meta, right? They have the ability to understand the young generation, right? I mean, and every company, I presume, do a lot of research to understand what the young people really want. And
Hi.